In this exercise, you'll use some of the subassemblies that are shipped with Autodesk Civil 3D to create an assembly for a basic crown roadway with travel lanes, curbs, gutters, sidewalks, and slopes to an existing surface. Now note that the corridor assembly you build will be used to create a corridor model in the Creating a Basic Corridor tutorial. Let's begin by going to our Assembly-1A drawing in our Tutorials folder. Next, go to your Home tab, and then to your Create Design panel. Next, click on the Assembly drop-down and select Create Assembly. Now we get our Create Assembly dialog box. Let's go ahead and give it a name. We're going to call it Primary Road Full Section. We're going to go ahead and leave our defaults and then click OK. Now you'll see in our command line it's asking us to specify assembly baseline location. I'm just going to go ahead and click off into space right over here. The viewport zooms to the assembly baseline, which looks like this. So let's go about adding a lane subassembly. If the tool palette containing the subassemblies is not visible, go ahead and go into your Home tab and then look under your Palettes panel and then click on the tool palettes. In the tool palette, go ahead and right click on the tool palette's control bar. Then select Civil Metric Subassemblies. Next, click the Lanes tab. Now select this lane option, Lane Super Elevation. Next, focus in on the Advanced area within your properties and specify the following parameters. For side, we're going to leave it at right. For width, we're going to change it to 3.5. And potential pivot, we're going to change that to no. Next, in the drawing, click on the marker point on the subassembly baseline. Now we're going to add a curb subassembly. In the Tool Palettes panel, go ahead and click your Curbs tab. And we're going to start by adding just a general curb. Then in the drawing, we're going to pan over and select the marker point at the top right edge of our travel lane. Note that if you attach the subassembly to the wrong marker, you can move it to the correct location. Press Escape to exit the subassembly placement mode, and then go ahead and select your curb assembly, and you'll notice that we have a blue grip that appears at the corner. Go ahead and select that grip, and let's move it off to the side. Now select that grip again, and we're going to move it to this location right here by selecting the endpoint of this line. And then press Escape. And that's how you go about moving your subassembly. So let's go ahead and move it back. We'll select it again, select our grip, and then select the endpoint of this line. Now let's go about adding a sidewalk subassembly. In our tool palette, go ahead and select the Basic tab and select Basic Sidewalk. In the Properties under Advanced, go ahead and input the following parameters. We're going to leave the side at right, but the width, we're going to change that to 1.5. The buffer width, we're going to change that to 0.5. And buffer width 2, we're going to change that to 0.5 as well. In the drawing, select this marker at the top point of the back of curb. After that, we want to create a daylight. So escape out of the Subassembly tool, and under our Basic tab, we have this subassembly option, Basic Side Slope Cut Ditch. Select that subassembly, and again under Advanced, we want to keep the side at right. For a cut slope, we want to keep it at 2:1, and for a fill slope, we're going to leave it at 4:1. In the drawing, select this outside edge. Go ahead and press Escape, and this action ends the subassembly placement command. Now we're going to mirror the subassemblies to the left side of our baseline. In the drawing, select the 4 subassemblies you just added, and then right-click and select Mirror. And then zoom in to our marker point, and click the marker point on the subassembly baseline. The subassemblies are now displayed on the left side of our assembly marker. The mirror command creates a mirror image of the selected assemblies. All the subassembly parameters except for the side parameter are retained. Note the parameters of the mirrored subassemblies are not dynamically linked. If you change a parameter value for a subassembly on one side of the subassembly baseline, the change will not be applied to the opposite side. So that's how you go about creating an assembly in Civil 3D. In this exercise, you'll change the naming template so that assemblies will include the side on which the subassembly is placed. For example, if basic lane subassemblies are placed on either side of the assembly, they're named Basic Lane Left and Basic Lane Right. Performing this task makes it easy to manage assemblies and subassemblies in complex drawings. Open the Assembly-1B drawing in your Tutorials folder. This drawing contains an assembly baseline that does not have any subassemblies attached to it. If the tool palette containing the subassemblies is not visible, click on your Home tab, go under Palettes, and click on the Tool Palettes tab. Right-click on your Tool Palettes control bar. Select Civil Imperial Subassemblies. Next, click the Basic tab and click Basic Lane. In the Properties, under Advanced, we want to keep the side at right. In the drawing, click the marker point on the assembly baseline. The right lane subassembly is now attached to the assembly baseline. Now in the Properties palette, go under Advanced and set the side to left. In the drawing, click the marker point for our baseline again. And now, as you can see, the left lane subassembly is now attached to the baseline. Go ahead and press Escape. Next, in the tool space, under our Prospector tab, select the Assemblies collection. After we expand our assemblies, you'll notice the right and left collections. You'll change the naming convention in the following steps so the additional assemblies that are inserted do not use the same name. So let's modify the subassembly name template. In the tool space, select the Settings tab, and then right-click on the subassembly. Click Edit Feature Settings. In the Edit Feature Settings subassembly dialog box, expand the subassembly name templates. And then along the Create from Macro row, click the value and select this button. Now within the name template, we're going to focus in on the property fields and select Subassembly Side. Highlight the next counter within this area between the parentheses and click Insert. As a tip, to display the subassembly name in the local language, use the Subassembly local name field in place of the macro short name. Click OK twice. Next, go back to your tool space and under Settings, expand your subassembly. Right-click under Commands, Create Subassembly Tool, and select Edit Command Settings. Now, expand the subassembly options. In the Subassembly Name row, click the Value cell and select Use Name Template. Then click OK. Lastly, we're going to examine the updated subassembly naming convention. In the Tool Palettes window, select the basic curb and gutter subassembly. In the Properties panel, under Advanced, we're going to change this to Right. In the drawing, select the marker point at the top right edge of the travel lane. Remember, if you attach the subassembly to the wrong marker, you can move it to the correct location by pressing Escape to exit the subassembly placement mode. In the Properties palette, under Advanced, we're going to switch to Left. In the drawing, click the point at the top left edge of the travel lane and then press Escape. In your Prospector tab, go ahead and expand your Assemblies collection. Notice that there are two new subassemblies, Basic Curb and Gutter Left and Basic Curb and Gutter Right. These names are more specific than those of the basic lane subassemblies. Now note that the next exercise demonstrates more best practices for assembly and subassembly naming in drawings that contain many corridor assemblies. So that's how you go about modifying the subassembly name template in Civil 3D. In this exercise, you'll apply some assembly and subassembly management best practices to a drawing that contains multiple corridor assemblies. Go ahead and open up your Assembly-1C drawing in your Tutorials folder. This drawing contains several completed corridor assemblies. The assemblies are designed to create an intersecting main and side road. In your tool space, under your Prospector tab, select the Assemblies collection. Go ahead and expand this collection. Now when we look at the list view, you'll see that there's a specific name that was assigned to each assembly when they were created. The names describe the type of corridor as well as the specific portion of the corridor to which they apply. In the drawing, notice that each assembly has a label that corresponds to the assembly name. The labels are just simple AutoCAD M-text that make it easy to see the construction of the available assemblies. In the command line, type in ZE for zoom extents. The drawing zooms out to the drawing extents. In the Tool Space Prospector tab, click on the main road assembly. Right-click and select Zoom to. The drawing zooms to the main road assembly. So let's assign some specific names to subassemblies. In the drawing, click on the main road assembly baseline. Right-click and select Assembly Properties. In the Assembly Property dialog box, go ahead and click on the Construction tab. Expand the collections in the item tree. The subassemblies that comprise the assembly are displayed in the item tree. Notice that the subassemblies are categorized into groups. Subassembly groups manage the order in which the subassemblies are processed during the corridor modeling. The first time you add a subassembly to an assembly, the subassembly is added to the first group. When you add the second subassembly to the first subassembly, the second subassembly also gets added to the first assembly group. The next time you select an assembly baseline, a new subassembly group is automatically created and subsequent subassemblies are added to that group. In the item tree, go ahead and click this subassembly. The subassembly parameters are displayed in the Input Values panel. You can modify the parameters as necessary from this panel. Right-click on the assembly and select Rename. We're going to replace this text with something a little bit more descriptive. I'm going to replace this portion right here and type in main road. I'm going to do the same thing with the rest of my subassemblies. And then I'll rename my groups. Then click OK. In the Toolspace panel, under the Prospector tab, go ahead and expand our assemblies, expand the main road and the baseline. You'll see our renamed groups, and you'll see our renamed subassemblies. For further exploration, you can go ahead and practice what you learned by renaming the subassemblies in the remaining assemblies. So that's how you go about managing assemblies and subassemblies in Civil 3D. In this exercise, you'll examine how the daylight subassemblies are applied to the corridor model and section. Let's go ahead and examine the existing corridor. Go ahead and open up your Assembly-2A drawing, which is located in your Tutorials folder. Now you'll notice that the drawing contains two viewports. You'll see how we have a completed corridor assembly, and we have a profile view. I'm going to go ahead and center my corridor assembly. Then I'm going to click within the bottom viewport. Select the corridor, and then we get our corridor ribbon. Next, go over to your Modify Corridor Sections panel and click on Section Editor. You'll see how our bottom viewport has changed to show our section editor. In the Section Editor tab, go ahead and click on these buttons to go to the next station. You'll see as you click how our section changes, and if we scroll a little bit further over, you can see a white section cut line, both on our plan view of our corridor and within our profile. So go ahead and continue to move through the stations, and you can see how those lines move. Let's go ahead and go backwards. You can see how our section is slowly changing. We can also quickly go to a specific station. Let's go to the very last one. You'll see how our section cut line goes all the way to the end of our station, as well as with our profile view. Let's go ahead and return to station 00. And you can see how that's reflected down here and within the profile view. So that's how you go about examining the existing corridor in a section. In this exercise, you'll add conditional cut or fill subassemblies to an existing corridor assembly. You'll do this by specifying two levels of conditional cut or fill subassemblies. In the first level, if we look at our completed assembly here, you'll notice that we have 3 of these yellow conditional subassemblies. Here's one for fill, here's another one for fill, and here's one for a cut. And you'll see that all of these are attached to this little object right here, which is a guardrail. I'm going to go ahead and zoom out a little bit right here so we can see the whole corridor assembly. After we've completed the first level, we'll move on to the second level of conditional cut or fill subassemblies. And that has to do with these ditch subassemblies that are attached to our first level. So let's go ahead and add the 3 conditional subassemblies within the first level. Go ahead and zoom in to our area right here. Within the Home tab and under the Palettes panel, go ahead and select this button right here for Tool Palettes. After that, go ahead and right-click on the Tool Palettes control bar and make sure you're on Civil Imperial Subassemblies. Go ahead and find the Conditional tab, and then go ahead and select Conditional Cut or Fill. After that, we get some new information within our Properties panel. Go ahead and look under the parameters of the subassembly. And for side, we're going to leave it on left. We have the choice for right here, but we're going to leave it on left. For layout width, we're going to change it to 20 feet. For layout grade, we're going to change that to a 4-on-1 slope. Oops. For type, select fill. And then for the minimum distance, we're going to leave that at 0. And for a maximum distance, we're going to type 5. Okay, we're finished with that. Go ahead and zoom into our little model right here. And you'll notice right next to our guardrail, we have this circle. Go ahead and select that marker. And you'll see if we zoom out, it places our subassembly. Now if you notice within the command line, our command is still active with our assembly. So if we wanted to, we could go back into Properties, and under Parameters, we can go ahead and start on our next subassembly. We'll go ahead and leave it on left, and we'll leave it at 20 feet for the layout width. But for the layout grade, we're going to change that to 1-on-1. For the type, we're going to leave it on fill. And for the minimum distance, just for this exercise, we're going to specify 5.0001 feet. After that, our maximum distance, we're going to specify 10,000 feet. So once that's finished, go ahead and select our marker right next to our guardrail. You'll see we have a brand new subassembly attached to it. Again, our command is still active, so we'll go and add our third subassembly. For the side, we'll leave it on left again. For the layout width, we'll leave it at 20. Layout grade, we'll have it at 1-on-1, but for this, we're going to change the type to cut. We'll give it a minimum distance of 0, and we'll leave the maximum distance at 10,000. So now that that's finished, we'll go back in, zoom in to our marker, and click. Zoom out, and we have our first 3 subassemblies. Now let's add a daylight bench subassembly. Go back into your tool palette, and if you can see right here, we have a daylight tab, but if you notice there's so many different tabs right here. One way to get past that is if you click down here at the bottom, you can get a list of all the different tabs. Kind of makes it a little bit easier to pick the one you're looking for. So we're going to go with the daylight and then select the daylight bench subassembly. Then go into your properties panel, and under advanced, we're going to keep it on the left side of our assembly. The cut, we're going to go with a 4:1. Max cut height, we'll go with 5 feet. Fill slope, we'll go with 4:1. Max fill height, let's go with 5 feet. Bench width, 6 feet. And then bench slope, we're going to go with -10%. And we're going to place it at the end of this bottom one right here. So go ahead and zoom into our little circle right here and go ahead and select it. Now if you notice that there is a difference between the daylight bench subassembly that we just brought in as compared to the completed version right here. Now the difference can be found within the parameters. Under version, you'll see that this was created in an earlier version of Civil 3D, released 2012. However, our version, if we select it, was created in 2019. But, not to worry, both of these accomplish the same goal within our corridor, so you don't have to worry about that. Next, we're going to move and copy some subassemblies. Go ahead and pan over to this ditch subassembly. Go ahead and select it, and then right click and select Move To. And we're going to move it to this fill subassembly. Go ahead and click this circle right here. If we zoom out, you see how that moves over quite nicely. After that, go ahead and click that subassembly again, and then right click and select Copy To. And pan up to the top to this cut subassembly and select this end of the subassembly, and there you have it. Next, we're going to add a second level of conditional subassemblies. We'll bring our palette back by clicking on the Home tab, then clicking this button, and right click down here at the bottom, and we're going to select Conditional Subassemblies, and go ahead and select Conditional Cut or Fill. Then zoom in way up here, and we're going to specify some parameters. We're going to leave the side on left. The layout width is going to be 12. But we're going to change the layout grade to be 0.5:1. Keep the type on cut. Minimum distance, we're going to specify 5.0001. For a maximum distance, we're going to specify 10,000. Then press enter. And instead of this hinge point, how about we select this hinge point? And we go ahead and zoom out here, and it matches our example, as you can see right here. Let's go ahead and follow the same process again for another subassembly. Click on Conditional Subassembly and specify the following parameters. Leave it on the left side. Layout width, we're going to keep it on 12. For the layout grade, we're going to leave it at 1-on-1. Type, we're going to leave it on cut. Minimum distance, we're going to leave it on 0. And for a maximum distance, we're going to change that to 5. And press enter. Then go ahead and select that same hinge point. Lastly, we'll add a third subassembly. Under the parameters, keep it on the left side, layout width of 12, 1-on-1, but this time we're going to change this to fill. Keep the minimum distance at 0, and then the maximum, we're going to change that to 10,000. And press enter. Then go ahead and select that same hinge point again. Lastly, we're going to add subassemblies to the second level. Go ahead and choose the Generic tab within your palette and select this subassembly, Link, Width, and Slope. Now specify the parameters. We're going to leave it on the left side. Change the width to 12. And the slope, we're going to change that to -2%. Go ahead and zoom into our cut, this big one right here. Select this end. Next, find the Retaining Walls tab. And select the Retained Wall Vertical subassembly. Click on that, and we're going to leave it on its defaults. Zoom into this area right here at the end. Select this right here. After that, go ahead and right click and select Generic again. Now we're going to select this subassembly, Link Offset on Surface. We're going to change this to be -60 feet, and then we're going to leave everything else at its defaults. Zoom into this area right here and select the end of this subassembly. Lastly, we're going to add one more subassembly. Go ahead within Generic and select this subassembly, Link Slope to Surface. And we're going to change its slope to 4%. And we're going to change this parameter right here, add link in. We're going to change this to fill only. Then go ahead and select this point right here, and here you go. It should look like, or pretty similar to, the completed corridor assembly. Go ahead and press Escape. And that's how you go about adding conditional subassemblies to a corridor assembly in Civil 3D. In this exercise, you'll adjust the properties of one of the subassemblies and then assign descriptive names to each of the subassemblies in the through road assembly. Now we want to make sure we give each subassembly a specific meaningful name to make it easy to identify when you're assigning targets. Meaningful names also help you identify subassemblies in the subassemblies collection in the prospector. This exercise continues from adding conditional subassemblies to a corridor assembly. Now we're going to start off by omitting the daylight link from the cut conditional subassemblies. Now note that this exercise uses the assembly-2A drawing with the modifications you made in the previous exercise. Or you can open up assembly 2B from the tutorial drawings folder. Now you might be wondering how I got this into a single viewport. Well, if you've never done that before, type in viewports, and you have an option of cycling between viewports. Here's where we were just at, the 2 horizontal viewports. We'll go ahead and type, or click OK, excuse me. And that's how you get 2 viewports. But for this exercise, we're going to stick with 1. So type in viewports again, and then click single, and click OK. We'll begin by going to this daylight basin subassembly, and you can see that it's labeled with the name daylight basin for TR-L. And you want to select the one that's attached to this conditional subassembly. Next, right-click and select Subassembly Properties. Now we're in the Subassembly Properties dialog box. Click on the Parameters tab. Select the daylight link, and under Default Input Value, we're going to change this. Right now it's set to include the daylight link. We want to change that. We want to actually take it out or omit the daylight link. Then click OK. Then we're going to apply this and click OK again. Now we're going to rename the subassemblies. We'll do this by selecting this red assembly marker, then right-click. Select Assembly Properties, and then we get our Assembly Properties dialog box. Click on the Construction tab. Then you'll notice that all of the assemblies are listed within this. When you build a complex assembly, you should assign meaningful names to the subassemblies so that you can easily identify them when setting corridor targets. This is also a good practice when a drawing contains multiple assemblies. In the next few steps, we're going to be giving the subassemblies more meaningful names. When I look at this item list, it looks a little bit overwhelming to me. So what I do is I more or less kind of make it a little bit simple by doing this. I'm going to be focusing on my left assembly. Click the plus icon, and then click on the conditional cut or fill, this first one. Now with this first one, if you remember, we have our minimum and maximum distances of 0 feet and 5 feet. Go ahead and click to highlight the text. And I'm going to go ahead and expand this. I'm going to right-click on the text and click Rename. And I'm going to abbreviate condition. And this is a fill subassembly for our left side. And I'm going to put 0 feet, 5 feet. And this is for TRL. Which is the through road for the left side. Then press enter. A descriptive naming convention helps to distinguish between the many conditional, cut, or fill subassemblies. As you can see right here, if we have a giant list of these subassemblies, you won't be able to keep track of which one you're dealing with. So we'll go ahead and rename the last 2 subassemblies. Oops, see, looks confusing already. Let's minimize this. We'll click on the next one, right-click, select Rename, type in Condition. This one is for fill, 5 and 10,000. For through road, left side. And if you scroll down right here, you can see that this type is for fill. And we've got 5 and 10,000. Next, go to the last one. We're going to select it, right-click, select Rename. We're going to abbreviate this again. But for this one, this is going to be for a cut. 0 to 10,000. And this is for through road left side. If we go through this one, you'll see the type is cut 0, 10,000. Next, we're going to go ahead and rename the daylight subassemblies. So just for simplicity again, I'm going to minimize these. And I've got a daylight basin for TRL. You'll notice that this looks like a descriptive name, but I'd like to add a little bit more information to it, such as whether it's a fill or a cut type. So what I'm going to do is I'm going to highlight this, click rename, and for this I'm going to put in, since it's a fill, parentheses FILL, fill, for through road left. That looks pretty descriptive. I'll maximize the next one. This is for a daylight bench, and this is a fill situation, but go ahead and click rename. But if you notice, it doesn't say anything about our through road left. So I'm going to type in daylight bench parentheses fill for through road left. Press enter. And then for the last one, this is a cut. Go ahead and select this, right click, rename, and we're going to call this daylight basin. I'm going to put my cursor right in between here, and this is a cut situation. So I'm going to put parentheses cut for through road left. Now let's go about naming the second level of subassemblies. Now, to save time, you can choose to skip this step. The sample drawing listed in the next exercise has all the subassemblies named appropriately. But I'm going to go ahead and do it. I'm going to click on this next one right here, right click, select rename, and I'm going to call this condition cut 0 to 10,000. And I'm going to go even further than that. I'm going to say cut 5 to 10,000 for TRL. And I'm going to go to the next one right here, right click, rename, conditional cut 0 to 10,000, cut 0 to 5 for through road left. Now for the last, right click, rename, conditional subassembly, fill 0 to 10,000, cut 0 to 10,000 for through road left. Okay, everything looks good. We'll go ahead and click apply and then click OK. So that's how you go about adjusting conditional subassembly properties in Civil 3D. In this exercise, you'll reset the corridor targets, rebuild the corridor, and then examine how the conditional subassembly affects the corridor model. This exercise continues from adjusting conditional subassembly properties. So let's go about setting the targets and rebuild the corridor. Go ahead and open up your Assembly-2C drawing, which is located in your Tutorials folder. The drawing contains the corridor assembly that you designed in the previous 3 exercises. In the drawing, go ahead and click on the bottom viewport and zoom in and select the corridor. After that, go into the Modify Corridor area and click on the Corridor Properties. In the Corridor Properties dialog box, click the Parameters tab. Then you'll see a button up at the top that says to set all targets. Go ahead and select that. And in the Target Mapping dialog box, there's a box right here underneath Object Name to set all. Go ahead and click that and select Existing Ground. Then click OK. Go ahead and click OK and then OK again. And you can see how the corridor is modified. Lastly, let's go ahead and examine the rebuilt corridor. Go ahead and select your corridor again, and then go to the Modify Corridor Sections panel and click on the Section Editor. Now currently I want to go to the 0 station, so I'll click the drop down and I'll scroll all the way up and click. You'll notice that in this section we have quite a bit of fill in this situation. And this is happening in the first few stations. If we continue to click. Now if you remember, in the adding conditional subassemblies to a corridor assembly exercise, you attached the daylight bench subassembly to fill with a conditional subassembly. The fill condition at this station is greater than 5 feet, so the daylight bench subassembly is applied. Let's go ahead and advance to station number 2. You'll see that this corridor section shows more of a cut situation. At this station, the cut is less than 5 feet, so the daylight offset to surface subassembly is applied after the ditch. Go ahead and click to 225. Now in this section, the cut condition is greater than 5 feet as you specified. The daylight width slope and the retaining wall vertical subassemblies are applied after the ditch. You can go ahead and continue to examine all the different sections, and you can see how the conditional subassemblies were applied. So that's how you go about rebuilding the corridor and examining the results in Civil 3D.